Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. So, my name is Dini Afif bin Anwar and my teammate is Khairul Hakimi bin Mat Yunus. So, today our topic is about the springs. So, the first thing I want to do is introduce you about how actually springs work, how it makes, what is spring actually. So, let's move to the next. Okay, the next slide is for introduction. So, what is springs? So, springs is actually a mechanical component that can store energy when the force is applied and release that energy when the force is removed. Okay, I give you 3 examples of it. First one is springs are essential component in hardware system. Easy to say that springs is actually important things that hardware systems need. Second one is spring is used to store and release mechanical energy. As I said before, a spring is actually a mechanical component that can store and release energy. So the third one is springs actually most found in machines, tools, and structural system. So the conclusion is the springs is very important in every component in hardware system. So let's go to the move to the next slide. So this slide will tell you about the deeper meaning is in springs. So what is actually spring means? A spring is a flexible mechanical object that can stretch, compress, or twist when a force is applied and return to its original shape when the force is removed. So the characteristic of a spring is actually to store energy and release when it's needed, as I said before. The second one is actually the different size of springs is different value of force. For example, the bigger springs, the bigger force is applied and removed. So lastly, springs work based on a Hooke's law that actually my friends will explain to you guys what is actually Hooke's law. Okay, let's go to the move to the next slides. Okay, in these slides, I would like to explain to you guys about material used for springs. So basically, what a material to make springs. So the first one is high carbon steel, which is that the characteristic is strong and durable. The second one is stainless steel. The characteristic is corrosion resistant, which is it is not actually easily to corrode. So lastly is alloy steel, which is very common in making springs, which is it's high performance springs or high performance material characteristic. So this material is actually affect strength of the springs, flexibility of the springs, and lifespan of this spring. So these slides I would like to tell you guys about type of springs in hardware. So the first one or the first type is compression springs. These springs are usually common in the work field now. So the second one is extension spring. There's a little bit different from the compression springs. And the third one is torsion spring. So torsion spring. And lastly is leaf spring. So leaf springs is actually a heavy duty springs that used for cars, for the vehicle, like that. So there's a type of springs in hardware. Okay.
So now let's move into important engineering principle called Hooke's law, as mentioned by my friend just now. So Hooke's law explains how a spring behaves when a force is applied to it. Basically, it tells us that the force applied to a spring is directly proportional to how much the spring stretch or compress. In simpler terms, the more force you apply, the more spring will deform, but only up to a certain limit. This concept is extremely important in aviation engineering because aircraft components must behave in predictable and controlled way. For example, when aircraft land, the landing gear experience very force due to the weight of the aircraft and the impact with the runway. The spring inside the landing gear systems must compress and absorb that energy. If the spring compress too much, it can fail or damage the structure. If it compress too little, it won't absorb enough energy and the impact will transfer to the aircraft body. So, engineers use Hooke's law to calculate exactly how much force a spring can handle and how much it should deform under that force. This ensures that the system remains safe, efficient, and reliable during operation. So for this slide, we look at the spring constant, which is usually we represent by K. The spring constant tells us how stiff a spring is. A higher value of K means the spring is stiffer and require more force to deform, while a lower value means the spring is more flexible. In aviation, selecting the correcting spring constant is very important because different aircraft systems require different level of stiffness. For example, in landing gear system, the spring must be very stiff to absorb higher impact force during landing. On the other hand, in control systems, spring must be more sensitive and precise to allow smooth and accurate movement. Material selection also plays a major role. Aircraft springs are commonly made from high-performance materials such as alloy, steel, or titanium. This material provide high strength while keeping the weight low, which is very important in aircraft design. Additionally, the shape of the spring, the thickness of the wire, and the number of coils all affect the spring constants. So, engineer must carefully design and select both the material or the geometry to ensure the spring perform correctly under operational conditions. Now, let's talk about how spring used in aircraft are manufactured. In aviation, manufacturing quality is extremely critical because even a small defect can lead to failure, which is unacceptable in aircraft systems. The manufacturing process usually starts with coiling the spring either through cool forming or hot forming, depending on the material and size. After shaping, the spring undergoes heat treatment. This process improves strength, elasticity of the material, allowing it to handle repeat load without permanent deformation. Another important process is surfaces finishing. These include techniques such as coating or plating to protect the spring from corrosion, especially since aircraft operate in harsh environments like high humidity, temperature change, and exposure to chemical. Additionally, processes like short pinning are used to improve fatigue resistance. This is very important because aircraft springs are subject to repeat cycle of loading and unloading. Finally, every spring must pass strict inspection and testing standards before it can be used in an aircraft. This ensures reliability, safety, and long service life in real operating conditions. One of the most critical applications of spring in aviation in the landing gear systems. When an aircraft lands, it experiences a very high impact force. Spring in the landing gear help absorb this energy and reduce the stress on the aircraft structure. This is not only protects the aircraft but also ensures a smoother and safer landing experience. So next, we talk about engine and components. In aircraft engine and mechanical components, springs are used in valve and other systems. They help maintain proper pressure, ensure components stay in position, and allow parts to move correctly during operation. Without these springs, many engine functions will not work efficiently or reliably. So for this last slide, we want to conclude about it. Springs are small components, but they play a very important role in aviation engineering. They are used in critical systems such as landing gear, control systems, engine, where reliability and performance are essential. Aircraft springs must be designed to withstand high loads, repeat stress, and extreme environmental conditions. This is why material selections, precise manufacturing, and proper design are all crucial factors. Engineer must ensure that every spring performs exactly as expected, because even a small failure can lead to serious consequences. So overall, springs are not just simple components; they are essential elements that contribute to the safety and efficiency of the entire aircraft systems. Thank you.